I literally watched it 5 days ago, and I checked the meetup thing when I got back into Colorado. I was like, oh, good timing.
Reinforce.
He's going to reinforce.
Yeah.
So see, yeah, it's recording.
Yeah, you're good. I trust
we're good.
you. I trust you.
Yeah, it's interesting. It's interesting to see how the community will go over time.
No, I guess that means I don't actually know,
she used to work on our stuff.
I feel like it would be really convenient if someone had a breathalyzer right now, so I would know where I'm at. Because I gave the talk last year.
Yeah, I'm not too excited
like
about it
perfectly
either.
buzzed, and then did Rails comp sober, and I
meant to be
immediately
like
fell
go
over
format.
giving
So,
the talk.
it's,
Like if I didn't have a podium to hold on to, I was like ready to like literally face.
in a certain style.
It was really bad. Like I was like I physically like couldn't move. Like the fact that I had a remote was really important because I like couldn't move my arm for like 5 minutes.
Yes, I will say that was not obvious.
The video makes me look way better. Usually it's the other way around. The video makes you look worse. No, and now you can tell. Oh, yeah. I have like my little notes for myself to like pump myself up.
I think that
All right, everybody ready? I wish I could actually whistle. There it is.
Hey.
85%.
Yeah.
All right, so this is the second talk, and this is a kind of our format I think we're aiming for, is a lightning talk and a longer talk. Yes? Dan says yes, so that's what we're
If
doing.
anyone wants to give a lightning talk or a longer talk, come talk to me.
Yeah, and that's also something we forgot to say. If you want to give a talk, talk to Dan, and it's really fun to give a talk even if it seems scary. I think we mostly know that we're pretty good people and supportive and welcoming, so.
It is scary.
It is scary, but don't let that scare you. And so at that, come on up, Joel, and give us your follow-up talk to your RailsConf talk.
Oh, thanks. All right, here we go. So I have a secret to share with all of you. The future of Ruby on Rails is already here. The future of Ruby on Rails already exists. And it's in your applications. And it's in your gems. But it won't be the future of Rails unless you share it with the rest of us. So Rails has been around for a long time. It's been around since 2005, which you can think of as basically an eternity in internet time. And yet somehow Rails has managed to stay relevant. This isn't by accident. Rails has evolved through features and fixes that have been extracted from other Rails applications. So today I'm going to talk about an extraction from the GitHub monolith that I've been working on for the past year. It's called Action View Component. I'm going to talk about why we built it, the lessons we've learned in the past year using it, and our vision for the future of Rails views. But first, I figured to introduce myself. I've never really formally introduced myself to this group before, so this is going to take a little while. My name is Joel. I work for GitHub. We are fully distributed. Most of our engineers are remote. I think at this point, I checked the other day, 80% of our engineers are remote, 20% are in San Francisco. At this point, I think we're about 2,000 people for the whole company. Pretty big company. I live just south of Boulder. He has a wonderful picture of me, my wife, Caitlin, and our 90-pound golden retriever, Captain. He is the closest thing I get to human contact most days, working from home. But before, yes?
Do you not see your wife every day?
Is she not human?
Anyways,
tough crowd.
so something I've never really shared with you guys is that before I was a software developer, I was a photographer. This is a picture of me the first time I ever came to Boulder, Colorado for a Sports Illustrated workshop at the CU Stadium, shooting football. So I spent a couple of years traveling the country shooting football for the university I went to, good old Ohio University in Athens, Ohio. I shot portraits for marketing materials. This was on a billboard the size of a 18-wheeler. I covered every sport you could imagine. I worked covering NASCAR races. This is a picture from a NASCAR race in Martinsville, Virginia. Worked in newspapers for a while, covering the kind of like daily life fun pictures that capture the spirit of communities. This is the first day the swimming pool's opened in Grand Rapids, Michigan. One of my favorite pictures I've ever taken. I also covered some of the sadder parts of daily life. This is a picture from a car crash in right near my house in Carbondale, Illinois. This is a mother being carried away into an ambulance while her daughter is being comforted by her aunt. So I worked in newspapers for a while until a very fateful day in 2013. It was September 11th, and I was out biking on the Blue Ridge Parkway in Roanoke, Virginia with my friend Bryce, and I got a call from my boss, well actually my boss's boss, telling me that my boss was being laid off on her birthday on September 11th. That was pretty rough, but what was really rough is that I had aspired to become her. That was my goal in my career, was to become a photo editor at a newspaper. The one I worked at was pretty well known, so my goal was to have her job. And in that moment, I realized that I was watching the future of my career vanish from in front of me. So, luckily for me, I had a friend named Aaron Snyder, who some of you know. I used to frequent the meetup. So I gave Aaron a call, and I asked him for his advice, and he gave me something better than advice. He gave me an offer to be his apprentice at a little agency called Mojitech that was then based in Rhode Island. I guess it still is. They now have an office here in Boulder. Moved to Rhode Island, worked in this tiny 8x8 foot room that had really poor ventilation. And we worked really long days for a couple of months, and Aaron taught me Git, Ruby, Rails, JavaScript. He taught me how to be a professional. And I wouldn't be here without him. And I'm really thankful for that. So, enough about me. You know, this time of year, I was writing this talk starting right around Thanksgiving and now over Christmas, and it's a time of year that I like to be thankful. So, to reflect on that, I want to say that I'm thankful for your time. Time is a precious resource. And I think it's worth mentioning that, like, we recently lost someone from our community. Prakash actually spoke at Boulder Ruby a couple of years ago. I remember he spoke when we were back in the old Pivotal Labs office. You know, it's crazy to think that, like, he got brain cancer soon after he spoke to all of us, and passed away on Christmas Eve at the age of 47, leaving behind a daughter and a wife. And kind of puts a lot of things in perspective, right? Like, you know, up until a year ago, I hadn't lost anyone in my life. And since, you know, starting a year ago, Prakash has been the 5th person that I've lost in the past year. And it's been really a struggle for me. I didn't know how to cope with this kind of stuff. I sought help, actually, through Sondermind. Incredible. I found an incredible therapist. I tell you what, guys, if you haven't seen a therapist, go see a therapist. You don't know what you're missing. And I'm doing better, but, like, it's really been a struggle. But it's also been a gift. And the gift of all this struggle has been one of clarity. It's given me a source of clarity to make me realize how finite our time is that we have together here. And it's motivated me to use my time in a way that matters. So one of the books my therapist had me read was by a philosopher named Seneca called On the Shortness of Life, and I wanted to read this quote. "We're tight-fisted with property and money, yet think too little of wasting time, the one thing for which we should all be the toughest misers." Something I think that is incredibly relevant for a bunch of people that make a lot of money, but have the same amount of time as everyone else. So thank you for spending your time with all of us tonight. It is valuable and it is precious. I'm also really thankful for this community. You know, this meetup has been around for well over a decade. It's almost as old as Rails, right, Marty? Older?
2006. 2006,
so Rails is 2005, yeah. Rails wasn't really a thing at that point anyways, so. I'm also really thankful for our sponsors. I mean, we're in this beautiful space that can hold way more people than I thought were gonna be here tonight. And we're eating pizza paid for by sponsors and drinking beer and just enough wine to give this talk. And we have this, you know, this beautiful place to meet, and, you know, maybe one day Sandy Metz will come here with the money we have left over, right? Right, Rylan?
Fingers crossed.
Yeah, fingers crossed. Okay, and you know, I'm also thankful for the organizers, Dan, Rylan, Marty, everyone else who's contributed along the way. It wouldn't be possible without you guys, and I really believe that you guys all make this special. I've been to a lot of meetups, and this place feels damn like family, right? It's pretty incredible. So thanks. I tell some people that this meetup is so good I'd still come if it was a JavaScript meetup. So, on that note, thank you. I'm very thankful. So I'm also thankful for Rails. Rails has been around. Oh, Dan, what's up?
But would you come if it's a PHP meetup? No.
Definitely. It's faster than Ruby.
Oh, fair enough.
I can't compete with that. So Rails has been around for a long time, right? I think for a moment we should think about all the things Rails has helped you guys accomplish in your careers. That's something to be thankful for, right? Think about the value Rails has brought to the world. Rails has enabled us to focus on the needs of the people who use our products and not just boring things like CSRF protection. The value of Rails really comes from what we don't have to worry about anymore. And Rails is a big part of GitHub's success. GitHub is still a monolith. In fact, we're moving, I need a term for this. I've been using rehoming. We are bringing things back into the monolith that were extracted from previously, which is, I think, pretty interesting. And as of a year ago, we happen to be a $7.5 billion monolith. So last time I gave this talk, I got a lot of questions about give me the stats. What's it like? So here you go. Here are the stats. First of all, best repo name ever, right? It'll 404 for all of you, but that is the repo. It has 700,000 commits. It's 12 years old. Bunch of other things. Rails has scaled really great with GitHub. I think that Brooke has been in our code base before as a consultant, but he will tell you our app is really vanilla. You'd be surprised how boring the GitHub app is as Rails new versus what you see in our app. The folders look very similar. There's just a lot of it. So we have over 700 models. And so I did these same slides at RailsConf, and I had to update the numbers. I think this number was low 600s in April. We have over 600 controllers. It was 500 in April. We have over 4,200 views. That number was 3,700 in April. So literally in a year, we've added 500 view files, which I've worked on apps that were way smaller than that. And we've added that to our monolith since the spring. Our code base is 12 years old. And in the past year, 800 people made some contribution to that repository. That's a monolith. All right, so I'm often asked about what is it like to work on a code base that size, right? So the interesting thing that I like to share with folks is that there's a fundamentally different mindset that we have when working on a code base of this size. And I remember someone saying something right when I joined the company that really struck me. If it doesn't have to do with our business, it needs to go in Rails. So in other words, our strategy for writing code was to upstream by default. But it was not always this way. So before I joined GitHub, we were on a fork of Rails and Ruby for years. And the reasons for this are very complicated, but we were inventing features before they were in Rails. We were inventing things we had a background job adapter that was better than Rescue at the time, before active job existed, right? But this led to really unsustainable maintenance. So we had to backport every security fix that went into Rails, and that became increasingly complicated. It's really hard to onboard people because they had to learn GitHub Rails that was a long-running fork of effectively 3.2. So we had a team, including Brooke. No, that's not public information, but including Brooke. That spent oh shit, I'll edit that out. Maybe this isn't going on YouTube. So that team spent 2 years, not Brooke, but Brooke was on the tail end of it. The team spent 2 years getting us from a fork of 3.2 to being on master. And let me tell you about how awesome it is to be on Rails master. There's a lot of benefits to it, but the most critical thing is it made it easy for us to contribute to Rails. Because when you commit to Rails, there'd be a month lag in between that commit landing in Rails and it running in production in our code base. So if it could wait, and it would make sense to add it to Rails, we just add it to Rails. This enabled extraction. This is why you'll see, you probably didn't really see this, but like when Rails 6 came out, I think there were about 100 pull requests that were extractions of code from GitHub into Rails. And that's precisely because we were so close that that was just like our way of doing business. So I think DHH said it best in 2007, that the best frameworks are, in my opinion, extracted, not envisioned. And the best way to extract is first to actually do. So today I'm going to talk about an extraction that I thought was too obvious to ignore. So the first time I saw this extraction was in that first job at Mojitech. It was a consultancy. I was working on piles of Rails Rails projects, and I finally landed on my first like big, meaty Rails application. It was in production. It was a big Y Combinator startup. They were hitting massive scaling issues. But this was the first time I saw a Rails folder that was not conventional. And that folder was called Decorators. And it felt a little weird as a new Rails engineer. I didn't know what to do with this thing. And I really didn't know if I should be okay with it. But anyways, Decorators are model-specific view logic. They look something like this. You can think of Decorators as like traditionally in Rails, they're implemented as like a wrapper of an active model object. They're kind of like a dumping ground to put view-related code that is somewhat coupled to an active record model. But that could just be a concern, right? The nice thing about these is that you can still unit test them, like you can unit test your models. You're not putting all your view-related code on your model, so it's better than nothing, right? So the second time I got a hint about this extraction was working on another application that was using React to build its user interface. But it was a slippery slope. And this application was using React Rails to build UI that could have just been Rails templates. There was nothing dynamic about it, and that was really fishy to me. I learned later that we were using React Rails because it enabled us to unit test those components, which meant that we could get way more test coverage at a much lower cost for those components than if they were Rails views. So it looked something like this. So you'd have like in your template, you'd have like this is the React Rails syntax. You have like React component button, you pass in a label. And then when you write your test in JavaScript, you can literally just wrap the component passing in like the label and then asserting that the thing that gets rendered basically is the HTML that you expect. These are really fast. These tests are basically free. I would consider them free in the grand scheme of things. So the third time was actually when I joined GitHub. We had a folder, it was actually called View Models, but the pattern is called Presenter. And presenters are basically view-specific logic. So instead of being coupled to a model, they're coupled to a view. And that logic is extracted to Ruby objects. So it looks something like this. So this is a very convoluted example. This is somewhat actually from our code base. So you have a class that inherits from some sort of base view model class, and you define methods on it. And then you inject an instance of this into your view, and you call methods on that instance. This is easier to test, but in my opinion, this is ultimately a distraction, because while these objects are easier to test, you're not actually testing the view. You're just testing this intermediate object that no one really interfaces with besides this one template. They also happen to be very coupled to templates. So like when you look at that class name, there's little ambiguity that this is going to be repositories index that takes this thing, right? Like it's basically just like a sidecar file for a view. So the fourth time I encountered this problem was in an app that had a lot of logic in its partials. I'm guessing this is probably one of the more common things that you guys have seen. This actually also happened to be the GitHub application. So this does simplify logic. You can write that same method right inside your view, right? Just assign it right to a variable and then use it right in the template. The problem is that Rails doesn't really give you a way to test your views. And we'll get into that more later. But imagine this, but with like 25 lines here before the actual view gets started, and that's more like what you'll see in the GitHub monolith. So all the while I was thinking about this, I kind of watched the rise of popularity of what people are now calling components. Most popular in the React ecosystem, right? I think it's clear at this point, it's 2020, React is still around, it's probably not going anywhere. But at the same time, design systems were also becoming popular. This is where you'd see things like open source ones would be like Bootstrap, right? Like you can go build an app and design an app using Bootstrap without having to come up with your own designs for things. You'd also see companies coming out with them, like Salesforce I think is a pretty popular one. We have one at our company, it's called Primer, and we try and use it everywhere. And I think it's clear that that trend is continuing to today. So that's what I've seen. What have you guys seen? So I asked I shouldn't say all of you. I asked some of you on the Tech Friends channel to share your app folders about a month or two ago. And it was because I wanted to see how much my opinion was reflected in reality. And it was. So a couple of you had decorator folders. A lot more of you had presenter folders, those view-coupled objects. And plenty of you actually had both. Which is especially troubling to me because if you're going to come up with an abstraction for views and put it in your application and make everyone using your application learn it, pick one, right? Like, just pick one. Also, like, some of these are actually are two of the same kind, right? Like, components and view models are actually probably both view coupled. I could understand maybe having components and decorators because one is more coupled to the model and one is more coupled to the view. I'd love to see what those code bases look like. But more than half of the responses to the survey had view-related abstractions in their application folder that were not provided by Rails. And in my experience, every app I've worked in that's been at any amount of scale has had one of these. And you can also see this trend in the Rails ecosystem if you look at some gem statistics. So like, there are two popular gems for these patterns, Draper and Cells. Draper is a decorator library, so model coupled, and Cells is a view coupled library. I think they're in the millions. So I think it's something clear. There's something clear here, which is that something is missing from Rails. If we're all doing it, we're all adding it to our applications, maybe Rails should do something about it. So I think we have to first ask, why did we turn to these abstractions in the first place? Why are we breaking from convention? Maybe the most valuable thing Rails gives us as engineers. So in talking with many of you, it really comes down to writing tests. So why aren't Rails views easy to test? So this is one of my favorite diagrams because I think it very clearly expresses the cost-benefit analysis of various types of tests. So we have a y-axis that is both speed and cost, with UI tests being the most expensive, service being somewhere in the middle, and unit being the cheapest. So when it comes to views, Rails provides two levels of tests. It provides controller tests at the service level, and it provides UI tests, which are called system tests, I think that's the word we've come up with for them. But it doesn't provide unit tests, the cheapest, fastest option. So as our apps grow, we often turn to these view objects that can be unit tested that enables us to add more thorough coverage to our applications without like paying the super high cost of controller and system tests. So for reference, like some stats I can tell you that like in our application, controller test, for example, takes 6 seconds to run for every example. A unit test takes roughly 50 milliseconds, which means that you're looking at an order of magnitude. I think it's like, it's like 2 orders of magnitude, 100 times. It's a big difference. Our test suite takes about 20 hours to run, but only runs in 7 minutes because of parallelization. So needless to say, there's a strong deterrent to get thorough coverage for your views with the tools Rails gives you because they're so slow. So even if our views could be tested, I think this points to a bigger issue. And that's one of encapsulation. So this is where I get real nerdy. According to the Fountain of Knowledge Wikipedia, encapsulation, in object-oriented programming, encapsulation refers to the bundling of data with methods that operate on the data, or the restricting of direct access to some of an object's components. Encapsulation is actually probably just the definition I would give for OO. Like, if you think about the benefit of OO, it is encapsulation, and that's just my opinion. That's the thing that I get out of it. I'm sure there are other benefits. And Rails does provide encapsulation some of the time. So like, models are encapsulated, right? Like, so say we have like a user model. If we have a public method named main, that's bundling, right? Like, we're bundling up like a method on that object. And then if we have a callback that runs on a private method, that is restricted from direct access. So those are your two definitions of encapsulation right there in a user model. So if we're going to test this, we're going to write a test against the public interface. Our user's name is Rylan. But we're not going to write tests against those private methods, although there are ways. Rails controllers are also encapsulated. So again, if we have an example users controller, we have a public show method, bundled, and a private current user method that is restricted from direct access. Now our tests are slightly less direct, but we're still interfacing, in theory, with that show method. Note that like generally we don't test that current user method, generally. Indirectly, maybe. So what about views? So the closest thing to encapsulation in views, if we look at our example from earlier, is that kind of like local variable assignment. And as for testing, well, we don't really have a public interface for views, right? Like, how do you reference, what even is a view, right? So to see why encapsulation of views is an issue, we really need to understand how they work. And this is where the next 20 minutes of your life are going. So when I set out to answer the question of what to do with all of these trends that I was seeing in the Rails ecosystem, I really felt I needed to understand what views are. So what follows is going to be an explainer of the stack trace to render a view in Rails. I'm already out of wine. So unlike models and controllers, views aren't objects. So let's go on an adventure. So we're going to take a deep dive into the explicit render of a partial from another file. So here's our example code. We've got an index.html.erb. It sets an instance variable of message to hello world, and then it calls render message, which is going to then render this little partial here, message partial that is an h1 tag wrapping an output of that same instance variable. So does anyone want to guess what happens when we render index.html?
That's a guess.
It works. So when I first learned about this is roughly what my face looked like.
Yeah.
So let's go on a journey. Let's take that render message call and see what's actually happening. So the first stop on our journey is an action view helper's rendering helper. It takes 3 arguments. This is literally what we just passed in: options, locals, and block. And we aren't going to pass any locals in today, but we'll talk about some of the implications of them. Options here you can literally think of as just that message that we just passed in. This method, for a lot of this deep dive, I'm going to skip most of the code because it's very, very verbose. But the interesting thing it ends up doing is it ends up calling this method render partial on this thing called view render. And if we dig into the state of that line at that point in time, view render is an instance of action view render. Don't worry about that too much. Self.class is this mystery object, mystery meat, that you can think of this as a Ruby representation of the view within which we are calling that render method. I'll have a better way of explaining that later, I think. And then options here is, again, that name of the partial message. So then we end up in action view renderer, the instance we just looked at, on this method render partial to object, which is effectively just a wrapper of partial render. But we've got a couple interesting things going on here. We've got lookup context, which is this object. It has, I couldn't find the public methods on it, but I looked at the instance variables, and there are 2 interesting ones. One is this thing called details that has a locale, formats, variants, and a list of all the types of templates the current Rails application can actually handle. It also has this thing called view paths, which is an instance of a thing called action view path set. You can think of this as the Rails application's record of everywhere you can find a view file. So if you've registered other places that you're storing your views, it'll be inside this thing. And again, we have our mystery meat. I need a better name for that thing. Whatever anonymous class that represents the view we're trying to do this all from. At this point, we've transformed our message into partial message in the previous method. Okay, now we're in partial renderer. So first the arguments. Again, we're passing in that context object. Now it'll be like the partial, what was it, like the hash with the partial key on it. So the interesting bit here, though, is this call to a method called findTemplate. And notice that it's passing in path. What is path? And template keys, which is the keys of any locals you're passing into that render call. So let's look at the state at this point. So if we call path, it's just message. That's still pretty consistent. Just a different name for the 4th time, I think, at this point. Template keys is the keys of any locals we passed in. In this case, we haven't passed any in, so this is an empty array. So when we call findTemplate, we get an instance of ActionViewTemplate with a fully qualified path to our template. This is like literally where you can find the source code for the template, and then any locals if they're set. So if we go back to the whole method, we pass that like mystery meat object context and that template we just generated to a method called renderPartial. Okay, I need a drink. This is the actual call stack. I'm sorry, if it was shorter, this would be shorter. But because it's a long call stack, my explanation is long. So in partial renderPartial, it takes that. Notice something interesting here? They keep changing the name of things, even though they're the same thing, over and over and over again. It was very confusing when I was reading the source code. So the interesting thing it does here is it takes that template and renders it, passing in the view and any locals. This is starting to actually sound like we're making some HTML.
In this instance, what are template and view?
So, okay.
Sorry.
View was context in the previous method.
Oh, okay.
So view is mystery meat.
Okay.
Locals is an empty array because.
And then template is
And then template is that thing that just tells us where to find the actual source code of our partial.
Okay.
Oh, man. Okay, I swear this will end eventually. Okay, so then we go into ActionViewTemplate and we pass in those same things. View locals, we just answered this question here. We add this thing called buffer, which is an ActionViewOutput buffer, which you can think of as just a place to throw all the HTML we're generating. This is almost like an accumulator. We're just going to shovel stuff in there with all the HTML we're building. The interesting thing in this method, though, where it gets really weird, is a step called compile. What? We're writing Ruby, right? The whole point of writing Ruby is that we don't have to deal with compilation. Well, there are other reasons, but so in ActionViewTemplate, this compile method has a somewhat helpful comment, so we'll start there. Compile a template. This method ensures a template is compiled just once and removes the source after it is compiled. So this method actually doesn't do a ton, which is why that comment is confusing. It actually just wraps a call to non-bang compile. But it does something fascinating here. It passes in mod, this variable mod, which is on the view, this method called compiled method container. And I'm going to spoil something for you here. That mod is literally just an instance of ActionViewBase. So this is literally like the base ActionView class in Rails that's being passed in at this point. And you're going to see why that's real weird real quick. So if we look at that non-bang compile method here, the really interesting part of this is a line called handler.call self-source assigning to code. So if we look at the state at this point, handler is an instance of ActionViewTemplate handler's ERB, which you can think of as a object that is meant to help us deal with ERB things. Our partial is written in ERB. Rails has correctly identified that we're handling ERB. Self here at this point is actually that template we were looking at before, so that should look familiar. And source here is the source of our template. So we're getting close, right? So we have the actual string representation of that partial we were working in. So when you call handler.call, or whatever this call was, you get this string. And that string is Ruby code. So let's take a look for a second. This is the output of handler.call, and this is our partial.
Oh, wow.
So the output of handler.call is literally this ERB translated into Ruby. Every handler under the hood works this way. So if you're writing Slim, Haml, you name your templating language, it's ending up in Ruby before Rails runs it. Through this process, swap out the ERB handler with your templating language of the day, and you'll see the same thing under the hood. So if we go back to the ActionViewTemplate class, at this point we've compiled our template into Ruby code. So code is just those like 4 lines of Ruby. So now we're going to use it to define a method. We're going to do some meta programming. So let's look at the current state here. So method name is you actually might have seen these in some of your error messages, depending on what parts of Rails you're poking with in your application. This method name is generated based on that path, along with some collision prevention, all those numbers, based on the keys of the locals you passed in. In this case, we didn't pass in any, so I'm not going to really dig into that too much. We're also going to set virtual path in this method to be the views path to that partial. And then code should look familiar. That's the output of the handler. And so what's going on here then is that we're generating a method, right? This is the code that line generates. Literally, this is the method in Ruby. That's the method name. Probably wouldn't be acceptable in code review, right? You probably wouldn't go over very well. That method takes 2 things. It takes local assigns and an output buffer. That output buffer, you can think of as we were talking about a minute ago, that is where you're going to send all the things that you're generating when you're rendering views in Rails. So the body is generated by that call to the handler, right? So we're literally injecting those 4 lines of the output buffer, assigning it to a method with this name. Oh my God, okay. So back in compile then, we take that generated method, we take mod, which is action view based at this point, and we evaluate this code and put some things in there to help us debug things later when an error is raised. But what happens then is that this is action view base at this point. Action view base has 3 methods on it that are compiled. And those methods represent all the views in our application, right? Demo, index, HTML, ERB, demo, message, HTML, ERB, and I didn't show you the layout, it's empty. But there's a method for it. So this is the end of the road. We're back in ActionViewTemplate. We've compiled our view. So all that's left to do is to run it. So let's look closer at the state here. Method name is that same method. Self is the template, and then there's that buffer, right? So really this is the end. So in run, we set current template and output buffer, and we call send. But it's just sending that method with any locals and the output buffer and any blocks, which means we can just kind of replace this and say, this is effectively what we're doing. We're calling that method at this point. So that's the entire call stack for rendering a view in Rails. I'm done. No. We're only halfway through this thing. Okay.
Question.
Yeah.
Not a question, but a comment.
Yeah.
If you thought that was gross, you should have seen how it worked in Rails too.
I mean, you look at in digging through this code, I encourage anyone to read the Rails source code. It's fantastic. Like, it's documented. You can tell people have tried and succeeded to make this simpler.
Yeah.
But
And also doing that made it about 1,000 times faster than
Yep.
it was in Rails 2, because it used to have to reevaluate the ERB template every time.
yeah, it was probably faster for me to explain it than to render a view at that point.
Yeah, I think Yehuda, I don't know if they're still available, but he blogged about this a lot, what he was working on
Yeah.
back in the Rails 2 to Rails 3. A lot of this came out of Nerd.
Yeah. So I'm guessing you're thinking at this point, what? Wat?
Wat.
So let's take a deep breath for a second. What does all of this really even mean? What are the implications of whatever the hell we just saw here? What does this even have to do with encapsulation? Also, wasn't that like a lot of work? So the first lesson here is that views are methods. They are not objects. And they are methods on the same module, which is really bad. Those methods are compiled in part based on the locals keys you pass into the render method, which means that Rails is dynamically generating a method for each combination of the name of a template and the local keys you're passing to it at runtime. So let's look at these templates again. Index.html.erb, message.html.erb, and let's run them through that compile step. So here's what we end up with. This is action view based. This is oversimplified, right? So we have two sibling methods now, one for the index and one for the message. So on action, this is all on action view base. So when we go to render the index, when the controller calls render index, it's calling this method. It sets the instance variable of message to hello world, and then it goes to render the message partial, which guess what? Gets just translated to a call to this function, which has access to that message instance variable because we're on the same class. Does that make sense?
Yeah. Okay.
Okay, the sound in the room makes me think that makes sense. Does
Yeah.
anyone not understand? This is like the key part of what I'm talking about. Does that make sense? It's one instance for every view. So this is what I would call a global scope explosion. This is every view in your application. All your view helpers are also accessible on this object in the same context. And because it's all the same instance, they can all share state. I don't think that's much in the way of encapsulation, right? So in our application, we have 4,200 views. All of them are on that same object. And every combination of the locals passed to them. And those views are not going anywhere. So what might encapsulated views look like? Well, you guys already know, because you have them in your applications, at least in some form, right? Decorators, presenters, and components, these solutions have all made our views or something view related easier to test. But what I wondered is, why not just solve this problem in Rails? So that's basically how I spent 2019. Incorporating these views into a vision ultimately many of us at GitHub had for how Rails could address these issues. And it's called Action View Component. And I think it incorporates some of the best parts of these existing patterns into the Rails architecture and mental model. So first and foremost, Action View components are encapsulated. Instead of having one object for all of your views, you have one object per view. So let's look at this example component. I'll give you guys a second to read this code. There's kind of three things going on here. We have our component Ruby class, message component. It has validation, like a model. Active model validations, guys. They're great. It has an initialize method, explicitly takes an argument, it assigns it to an instance variable. That Ruby class has what we're calling a sidecar template. This template exists in the same directory as the Ruby class. It then references that instance variable. And just for reference, this is how you render the damn thing. Render, class name, argument. So off the bat, there's something fundamentally different going on here. Instead of passing a string in for that first argument, we're passing in a constant reference. And constant lookups are really fast. Like literally, if we were just referencing constants in render, I wouldn't have had to give you that 20-minute explanation on how we derive methods from strings that are passed into render. So if we look at the render call, that component is referenced directly, right? Another nice thing here is there's no ambiguity, right? So like you can reference impartial template names, or you can reference just like render show. You don't have to specify like render repositories /show, and Rails just kind of figures it out. In this case, you can literally do a constant search in your text editor, and you're going to know exactly what you're rendering at that point. So if we look back at our component, I'll save you the details of doing another stack trace, but just know that we do a very similar compilation step with our template. But instead, we attach that template inside the component object, rather than to like a global instance of Action View base, which means that this component, when it's rendering, doesn't have access to state from other views, and there's no instance variable leakage. Does that make sense? Okay. Yes, Dan?
I just want to know, like, back to globals,
Uh-huh.
like, how is there not collision between instance variables that are named the same thing in different views? Is just because at runtime gets assigned that
Yeah.
one in compilation, and the next time that the thing gets rendered, it gets assigned to
I mean, the instance variable assignment doesn't happen in compilation. It's just turning it into Ruby. So it's just like, I mean, you can assign an instance variable as many times as you want. It's just the last one that wins.
yeah.
And in theory, when you're writing your views, the last one is probably the one you wanted to win anyways. But I've been in some code bases where it wasn't, and it's really hard to untangle that. So this also encapsulates access to helpers. So helpers can be included in a component, or they can be passed in using a helpers kind of like escape hatch. You'll see this when you're trying to use view helpers in Rails controllers today. Unit testing components is simple. You can render them inline using our render inline helper, and then assert against the rendered result. The result is a Nokogiri HTML node, which means you can traverse it and extrapolate whatever assertions you want from your DOM. It looks a lot like writing a controller test, but without the controller, which means that it's really fast. These tests are 50 milliseconds. They're not nothing, but they're basically nothing. And what we found is that because they're fast, we write a lot of them. Like a typical component, you might see like 30, 40, 50 tests, because we can. So we published this as a gem in August as our extraction from GitHub. This was actually my first open source project I've ever done, and I've been blown away by the support I've seen for this project. I think today is the 20th release. I don't think I actually pushed it. Should have used your gem, bro. So we've been at 20 releases since August, but what's been really cool about this project is that since August, almost all of the work has been done by the community and not by me or anyone at GitHub. We've had 24 contributors from 8 different countries, and I'm going to share some of those cool contributions with you guys. So I started with some simple things, adding support for generators. This was added by a guy named Vinicius Stock. He works at Shopify, which is great because it means Shopify is using our library. This is definitely not going on YouTube. Shopify, I believe, is using our library in their checkout flow, which I believe if you were to assign a dollar value to Rails code is the most valuable Rails code on earth. But there is also some more complex features. A guy named Juan Manuel Ramayo from Argentina implemented component previews as a derivative / neighbor of mailer previews. So just like with mailers, these previews inherit from some sort of base class. Then you have a method for each preview. In this case, this is one we wrote for our issue badge that shows the state of an issue. And we have 2 previews, one for when the issue is open and one for when it's closed. And just like mailers, when you boot up your Rails app in development, you then get a place where you can look at your components in the wild. So when you click on one of those links, you actually get your component rendered by itself. Very fun. So for a while, we honestly just focused on looking at React and saying like, what of these things might make sense for server rendered UI? But now we're starting to think beyond that. We're starting to think about what we can do better than React. You know where this is going. So this just landed today. This has not been released yet. But a guy named John Palmer from Boston, 100 comments later, landed a PR for what we're calling with content areas. And let me explain. So you guys have probably seen components that look like this. This is what we call our box component. You might call it a card. Has a header, a body, and a footer. The HTML looks something like this. You got a wrapping box, you have a header, body, footer. Pretty simple, right? So if we're implementing this in React, there are some downsides. In our design system, when you're building this component, the order of those elements you put inside the box, technically there are some rules, right? Like you can imagine, you don't want your footer to be last. You don't want your header to be last. You want your footer to be first. You want to probably make sure that there's always a title and always a body. But because of the architectural constraints of React and really the way it uses JavaScript, you can only pass in one kind of block of content into a React component. If you guys are familiar with React, that's traditionally rendering children, right? Is what you would effectively output in your component. So one solution to this problem in React would be to have box take header and footer arguments, right? It's like maybe like strings. And that's better, but then it limits what you can pass in for those arguments, right? You might not be able to pass like another component in to render inside your footer. So if we look back at our example HTML, let's rewrite this as an action view component. So we'll start with a component that literally just renders that example code I just showed a few slides ago. So we have our box component, Ruby file, we have its sidecar template that is literally just the HTML I just showed you guys, and then I'll show you like an example render call. We're literally not passing anything into it. So this works, right? But let's make it a little bit more like our React example. So instead of just having everything in it, we'll render content, which you can think of as like our children that we have in components today. And we'll render those 3 components. So this is basically like exactly the React implementation, just in ERB and Ruby. But since we're writing Ruby, we can do better than this. And I don't know if any of you know where I'm going with this, but Ruby methods can accept multiple named blocks. So if we go back to our component, we can declare, using the syntax with content areas, multiple content areas for our component. And in the template that renders the component, we can refactor it, here's the turn, to use named blocks instead of separate components, which means that we can enforce, which means that the order that those things are declared doesn't matter. So when we go to render them, we can put the header where it goes, the footer where it goes, the body where it goes. That's a real improvement over JavaScript. So then we'll go back to our component at this point, and this is our original component. We'll rewrite it to instead render those content areas inside of our template, title, body, and footer inside the wrapping div. So looking back at our component, we can then use active model validations to require that certain content areas are set, and these will then raise an exception when rendering your component if you don't pass in your header or your body.
So can you go back to the previous slide?
Yeah.
So is it, okay, is it title or is it header?
Oh, you found a typo. Okay, write it down. What slide is that? 175? Okay. This is how we learn, guys. Oh.
You got it.
That invalidates my entire point. Should I even continue? Okay, so we can use active model validations. You can actually use this for any argument that's passed in as long as you set it to an instance variable. You can imagine enforcing, like, say you have like a component that has like, it can be different colors. You can make sure that someone's passing in a valid color. Like we have components that take like green, blue, red. If you pass in orange, it accepts. Validations are pretty sweet. And these are just active model validations. So anything you can write on a model today, you can write on a component, and we'll validate it before we render it. So this has made me wonder, what things can we do better than JavaScript? Also, Ruby is better than JavaScript. But anyways, another cool application of this gem is that since components are Ruby classes, you can put them in gems. We haven't done this ourselves yet. We were planning to, but I've actually been in contact with someone that I can't tell you where they work for. They work in the financial services industry, and they tell me that they already have a half dozen Rails applications using a single gem for their design system. And this is a screenshot they sent me. Like these buttons and these badges are all components that then give them consistent design across all their Rails applications, which is pretty sweet. They beat me to the punch. I was planning to do this for our components, but I just haven't gotten around to it yet. So unfortunately, this is internal. I can't tell you who it is. Not like you really care. But so what about performance? Well, I can tell you, at this point, this is not going on YouTube. We get 60,000 requests a second at the edge at this point, average, to our application. And it's been a non-issue, performance-wise, for us. So if it works for us, it's probably gonna work for you guys, right? The cool thing about the performance of components, though, is that one of the core foundational design constraints is we wanted to make it easier to make it fast. So let's talk about making components fast. So remember how we were generating a method for the unique combination of locals passed to a template at runtime? So let's see if I can explain this. This leads to like a really difficult caching behavior. So because they're cached at runtime, if you have a forking web server like Unicorn and Puma, every first request to a worker for that server is going to compile that template, right? So at GitHub, we're serving 60,000 requests a second. Do you want to know how many Unicorn workers it takes to serve the like 10,000 a second that get to the Rails app? It's like thousands, right? Which means that every time a request gets to one of those processes and that process hasn't rendered that view before, it's compiling that view, which makes it slower. So Rails 6 actually contained some optimizations around this that we pulled out of GitHub that are even more complex that I don't want to get into. But know that when you're working in your local dev environment, between 5 and 6, there was a change that basically said, when you load a page and then you load it again, it's not going to recompile it. That was actually a change that went into Rails 6. But I want to share some internal code that we've used to get around this, and you'll see why this matters for components. So this internal change is enabled by having a linter. And this linter does something fairly benign, but every time we call render, we require you to pass the entire path of the view. And that linter actually then goes and looks up and makes sure that that path resolves to a template file or it fails your build. So if you can think about it, like in a controller here, this is a repositories controller. Typically, you wouldn't even have a render call at all, right? Because Rails implicitly just calls your show template. We A, require you to have a render call, and we B, require you to fully qualify that path. So in this case, repositories show, probably a view you guys look at every day. So we do something really tricky. So we scan every template in our Rails application for calls to render. And then we group those calls by that string that's passed to render. And then for each one, we find that unique combination of local variables and then do that 20-minute explanation I just talked about for every single one of them. And we do that before our web servers fork, which means that when they've forked, they have compiled versions of every single template in every permutation so that they don't have to do those on cold when you see us, when you try and load a page. You know, we're deploying every 15 minutes, so you could imagine that some of those processes might never actually get more than a few hits to a template before they get killed and respawn on a new deploy. So fortunately for all of this, you can kind of forget all of it because components are way easier to optimize. So if we look at this example component, this compilation step also happens before your web server forks into different processes, which means you're effectively getting that optimization for free without having to go through the linter step, let alone using code you actually don't have access to because it's in our code base. But like I said, we've designed this for optimization, and it's super exciting to see what other optimizations we can come up with. So if you want to give this a try, the easiest way is to migrate a view-coupled view abstraction, like a presenter or a view model, and that's exactly what we've been doing. We're working on having a linter that will basically say, okay, you can't use presenters anymore, you gotta use components. And I think one of the things that I kind of give as a sales pitch for this, at least from what we've seen, is that even if you're just refactoring your code, you'll see an immediate benefit in your tests. So if you migrate your unit tests from this previous abstraction, they'll be the same speed. But you can also migrate a lot of your controller tests because your unit tests can then be assertions against HTML, previously a domain you could only touch in your controller tests. You might also find missing test coverage in the process. I don't know about you guys, but I pretty much, as a habit, write controller tests for happy paths, not for like every single permutation of what my view can do. So what about new views? Well, I've seen people use components for entire views. Our rule internally has been, if it could be a partial, it could be a component. So I encourage you guys to start there. All right, so what about the future? Our goal is to eventually get this into Rails. I've actually landed a couple PRs over the summer that have started to add support for this syntax in Rails. Kind of doing it gingerly. Again, this isn't going on YouTube. DHH is a hard person to make happy, so we're doing this gently, slowly, incrementally. Maybe he'll be on vacation when I open the big one. And we're going to continue to integrate this more and more of this library into Rails as it matures. We're probably about ready to hit version 2 for the gem, and at that point we'll probably accelerate that process. So it's no secret, the future of Rails is inside your applications. Frameworks like Rails help us move human progress forward. They allow us to focus on new and important problems. And in a changing world, it's up to us to make these kinds of thoughtful extractions to keep Rails relevant. Our time is precious. How will you guys spend yours? Thank you. Holy shit, how long was that? Was that like an hour?
Yeah, exactly.
Oh man, I'm fucked. Oh man. Yeah.
Christian, are you still using the ACID pipeline, and or are you using Webpack or any other transpilers?
If I had like 2 hours, I could tell you like all of our thoughts on this. So,
Because one of the benefits, I mean, I'm just trying to, the transpiling aspects of
Yeah.
JavaScript is awesome.
yeah. What are you saying with when
Well,
you?
like when you'd have like CSS in one place, other components that would wrap for all the browsers, instantly write CSS once. You
Yep.
have to adjust all the shit in the views, which if you do it traditionally in the Rails way, you have to, I mean, sometimes you run into a bunch of conditionals and shit just for different browsers.
Yep. So you've thought about that. So a big rant in this talk was about encapsulation, right?
Right.
So in the JavaScript world, they've solved this issue by just obfuscating all of your CSS to hell. They assign a random class name, and you write your CSS in JavaScript, and it compiles at runtime in the browser in some cases. So people have asked like whether you could just like put your CSS or your JavaScript next to that component file. And you totally can, and you can configure Webpacker to do it. But I think it's a terrible idea. Because if you're a developer looking at your code base and you see a component file and you see this template that we've gone through a ton of work to make sure it is properly encapsulated by that Ruby file, and you see a CSS and JavaScript file next to it, you might assume that those files are also treated with the same level of encapsulation when they are totally not, right? The fundamental problem with CSS and JavaScript in a lot of Rails apps is that they are global. So until we have a solution for encapsulating those same constructs at the same level as the component, I highly discourage people from using this organization of folders for CSS and JavaScript, because you're just kidding yourself at that point. Even if you added, any tooling around it, I think it would be highly misleading and dangerous. What else? Bored you out of tears.
I was curious. So, all right, you guys are running this in GitHub. Then, what was the drop then in performance, right? Versus before versus now with the componentry.
We haven't. I mean, honestly, if you run some of the benchmarks we've seen, they're about equivalent to partials. In some cases, they are much faster, about 4 to 5 times faster in like a benchmark IPS kind of things, like a very high volume, like well statistically derived thing. What I didn't touch on, because I obviously didn't have time, was that we are looking at implementing a stripped down version of the component base class that has no access to any of the Rails helpers and has a fewer pieces of functionality that would allow you to write components that you could be much more confident were completely isolated, which means that you could say use them in a mailer, right? Like you guys don't, I don't know how many guys if you guys have extracted a view into a mailer. You don't know how much of your views are coupled to the request object until you do that. So we're thinking of implementing a base class that has no access to any of that, and that'll give you so for our design system, when you're rendering a box, you don't need to know shit about the request. That's cut and dry, right? So we want to be able to declare that programmatically. And then of course those components that go into the gems, if they're that simpler, cleaner version, you can have higher confidence that they're actually going to work on any Rails app you drop them into.
That's awesome.
Have you seen any difference in memory? I mean, obviously with everything you can plot for you guys, 4,200 templates in
Yeah.
one giant class that's created and then destroyed every request, basically. This seems to be.
It's not created and destroyed every request, because these are dynamically defined methods.
Oh,
They're defined onto the class, which means that it's the first time a request hits that. That's why the first request is a different performance profile than the other ones if you don't compile them.
But still, I would think there would still be some memory benefits to this, because it's more instance based. You move things, looks like more instance based, right?
This is where my good colleague Aaron Patterson, who helped me build a good chunk of this, would have a much better explanation. But it depends on the way I believe it depends on the way your server handles the forking process. If it's doing a fork where it's copying everything that's happened ahead of time versus like, it's like copy on write, I think is the term, but basically like if you're making a copy that you make local modifications to, or if you're making, or if it's like a shared copy within all the forks, that can affect that. I will say that generally when it comes to memory usage, what this really gives you is predictability, because you're gonna have your memory usage slowly grow over time as your more routes are hit in your application. Versus this, you know immediately what your memory usage is at boot time because everything's compiled. So there's trade-offs. You're technically probably gonna use more memory. If you have like unused routes in your app that are never hit, those would never be compiled. Now if they're components, they would be compiled. But there will be fewer of them because we're only compiling once. We're not doing the permutation of locals, which you're doing for the ERB files.
It'd be interesting to compare the GC too, because you're instantiating and destroying a whole lot more objects. And GitHub is restarting the web server every 15 minutes.
Never
Yeah.
problem, right?
So I will say that the way I actually built this gem, I gave the talk here like a year ago, and the talk here was like I was too scared to like tell anyone of importance at work that I had this idea, so I figured I'd tell you guys first. and then you guys said it wasn't a terrible idea, so one of the cool parts about working at GitHub is we have 2 Rails core team members. So I fired a message up to Aaron, who I'd never met before, and was like, "When you see this talk, tell me if I'm an idiot." And he replied back, and he's like, "That's a good idea." Which, when your first message from Tenderlove as a Rails engineer at a company you just kind of just joined, that's really cool. So I spent, my cadence in 2019 was every 2 weeks on a Friday, Aaron and I would pair for an hour. We'd talk about the most vexing things, and he would give me some things I understood and some things I didn't understand to work on for 2 weeks. And I know that some of the buttons he was pushing were specifically related to his work on the compacting garbage collector. There's also some subtle things buried in here around the support for types in Ruby 3. There's some things we don't do, and I really shouldn't get into that, but there's some things we don't do specifically so that if you wanted to use the Ruby 3 types, that this would be compatible with it. So there's some people that have been like, you should just do this thing slightly differently, so I don't hate myself 2 years from now.
I guess I'll just give the solely JavaScript perspective, some of it, but like it's interesting the precompiled part because that's like a massive thing now. Let's say again or whatever in the JavaScript world with precompiling like Gatsby and Next.js, all that stuff, like precompiling it, shoving out there CDNs, React, dynamically doing stuff on the precompiled stuff, but like it's so powerful not to have to, when it gets hit, you do a call, like it's already done. It's out there and it's in a CDN and it's cached forever and it does some things. It's like so powerful, and you can have it run on tiny systems that are tiny dynos at Heroku and have it work great. Precompiling is just super powerful. And it's cool to see Ruby doing that as well.
For sure.
So I have a question regarding.
Put it on the issue.
Yeah, I will. No, this is more around how you guys build components. So when we started looking at adding components to our application at work, we have a lot of, the idea was really similar to use our UI library as like components and build those. But sometimes on some pages we display our boxes smaller or bigger or whatever depending on it.
Mm-hmm.
So when you build components, do you keep like that kind of sizing stuff outside of the components? Or where like you would add padding or margin specifically in like a div app that you would then render the component inside of that? Or do you put that in the components?
So the call to the component, we have a shorthand syntax that our design system uses for like generating helper classes. We've implemented it in Ruby. It's an array of symbols that basically, or it's a hash actually. And that is passed to each component and it applies the design system rules to it, which are like utility classes. What's nice, so I can kind of expand on that. We pass in this hash that has like key value pairs, right? Which has led to some really interesting experiments. We have not put this in production, but we realized that if you have a component that takes a text color and a background color, technically you could write a Rails validation that is an accessibility contrast check. Pretty cool. There's a lot of weird stuff you can do when you start having like programmatic access to your design system. I won't even go on that rant, but there's like and actually the thing I can mention to you guys is that So I've done this as like my 20% time for the past year. As of today, this is my full-time job at GitHub. They just said, this is your thing now, which is pretty cool. So I'm hoping we can answer some of those questions a little bit more thoroughly when I have full-time effort on it. Anything else?
I was looking for this exact abstraction you were talking about last week, so thanks for naming it for me.
Cool. Open issues. Also PRs. I actually prefer PRs at this point. We have enough issues. Yeah, but yeah, please open PRs and issues. Thank you guys.
Congratulations on the promotion there too.
It wasn't a promotion.